Not in the way ghost stories usually go, with creaking floorboards and flickering lights, but haunted by something far more mysterious and cosmic in scale. Strange apparitions drifting silently in the vastness of space. Something is out there, lurking in the shadows of our orbital path, shrouded in darkness, eluding detection, and yet perhaps always watching. This isn't science fiction. It's science on the edge of the unknown. Among astronomers, there's long been a curious whisper. Rumors of enormous ghost-like structures that move in lockstep with Earth, occupying gravitationally stable regions of space. Some claim these celestial phantoms have been captured on camera. Their enormous misty silhouettes stretching across regions of space up to 9 times wider than our entire planet. Others say there's nothing there at all, just the cold, empty void. So, what are these mysterious figures drifting through the night sky? Optical illusions or evidence of something truly extraordinary, something that defies our conventional understanding of the solar system? Could Earth have not one moon, but 2 or more? I'm Alex McColgan and you're watching Astra. Today, we're investigating one of the most captivating enigmas in modern astronomy, a cosmic ghost story decades in the making. The elusive and controversial Cordillera dust clouds, or as some call them, Earth's ghost moons. Our tale begins in 1961. Kazimierz Cordillera, a Polish astronomer, was scanning the heavens when he noticed something strange. 2 faint nebula smudges in the sky hanging suspiciously near regions of space known as the L4 and L5 range points, locations where gravity reaches a delicate equilibrium between the Earth and the Moon. Now before we dive deeper, let's talk about rangy points because they are key to understanding this mystery. Imagine space as a cosmic game of tug-of-war. Earth and the Moon pull on each other with their immense gravity. And somewhere in that gravitational battlefield are 5 sweet spots, pockets of balance where smaller objects can essentially park and stay put. These are called range points and they're named after the brilliant mathematician Joseph Louis Lagrange who first described them in 1772. 3 of these points, L1, L2, and L3, are unstable. If you place a satellite there, it has to constantly adjust itself just to stay in place. But L4 and L5, those are the crown jewels of gravitational equilibrium. They form equilateral triangles with Earth and the Moon and are stable. Naturally, over time, things tend to collect there: asteroids, dust, maybe even something more mysterious. And that's where Cordillera saw his ghostly clouds. He claimed these ethereal shapes, barely perceptible to the eye, were vast clouds of dust suspended in place by the gentle tug of gravity. He named them vibration clouds. Today we know them as the Cordillera dust clouds or KDCs. But Cordillera's discovery was met with skepticism. In the 1960s, our observational tools were crude compared to what we have today. Photographs of the clouds were faint, barely discernible, and couldn't be reproduced in newspapers. Astronomers tried and failed to replicate his observations. Some concluded it was all a misunderstanding, nothing more than an illusion created by light and wishful thinking. And yet, the mystery refused to fade. In 1966, NASA took to the skies using a Convair 990 jet flying at 12,000 m to escape light pollution. And from up there, far above the glow of city lights, astronomers saw something. They detected the clouds both at L4 and L5, and even managed to photograph the one at L5. The orbiting solar observatory also confirmed their presence that year, detecting changes in brightness consistent with large dust structures. But the mystery deepened when future observations began to contradict these findings. In 1976, a new player entered the story. Siegfried Rosa of the Max Planck Institute. Using advanced simulations, he argued that dust couldn't survive at L4 and L5 for long. Solar radiation, gravitational disturbances from other planets, and the Moon's shifting pole would scatter the particles, making stable dust clouds impossible. Adding to the doubt, radar studies returned to nothing. A 1983 attempt using a 61 cm telescope in Arizona found no sign of the clouds. Was Cordillera simply wrong? And then in the year 2018, after decades of debate, false leads, and elusive sightings, the tide began to turn. The mystery that had haunted astronomers since the 1960s was finally starting to reveal its secrets. Not through a telescope perched on a mountain or a satellite scanning invisible light, but through something far more precise: polarized imaging. At the forefront of this investigation were three researchers: Judith Slisballow, Gabor Horvath, and Andras Barta, a team of astronomers and physicists who dared to look at Earth's ghost moons through a different lens, both literally and figuratively. Polarized imaging is a technique that filters light based on its orientation. It reveals how light scatters when it strikes a surface, allowing scientists to detect incredibly faint patterns that would be invisible to conventional photography. When sunlight bounces off microscopic dust particles, it becomes polarized, changing direction in specific ways depending on the size, texture, and composition of the particles. Using this method, Slisballow and her colleagues focused their instruments on the region around the L5 Lagrange point, one of two gravitationally stable pockets that orbit Earth in perfect harmony with the Moon. These spots had long been rumored to contain dust clouds, but until now, proof had always slipped through our fingers. What they found was astonishing. There, shimmering faintly against the blackness of space, was a telltale signature, light being scattered in a pattern that aligned perfectly with what theoretical models predicted for a cloud of dust. This wasn't noise. It wasn't atmospheric interference or a glitch in the equipment. It was something real, light bouncing off countless particles suspended in a delicate gravitational balance nearly 400,000 kilometers away. And to support these observations, the team turned to simulation. They ran advanced computer models tracking the behavior of nearly 1.86 million virtual dust particles. The results confirmed what theory had long suggested: under the right conditions, the L5 region can indeed trap dust for extended periods. This simulated cloud took the same shape and size as the one they had observed in the sky, a loose ghostly structure almost unimaginably wide and yet composed of particles so small they bordered on invisibility. But the true wonder of the Cordillera clouds lies in their fragility. Though they stretch across a region roughly 100,000 kilometers wide, nearly 9 times the diameter of Earth, the clouds themselves are incredibly faint. The particles that make up the cloud are tiny, measuring just a few microns across, smaller than a single red blood cell. They're more akin to smoke than to substance, spread so sparsely that even high-powered telescopes struggle to capture them. And yet, they exist, but they are not static. These clouds are dynamic, changing in shape, density, and visibility over time. They respond to the gravitational tides of the Moon, the pressure of sunlight, and even the shifting positions of other planets. The cloud may stretch, shrink, dissolve, and reform over weeks or months, always in motion. Imagine a great fog bank drifting across a windswept plain, constantly reshaped by unseen forces. That's what the Cordillera clouds are like in space. This dynamic nature explains the decades of inconsistent observations. Some astronomers captured them. Others, using similar methods in the same regions of sky, found nothing. The clouds may only become visible under precise lighting conditions or during brief windows when their density increases just enough to reflect light. And while the L5 cloud now has solid observational backing, its sibling at L4 remains more elusive. Perhaps it's more dispersed. Or maybe it hides in the glare of the Moon's reflected sunlight. Whatever the reason, L4's ghost remains in question. Zooming out, this entire story reframes our understanding of Earth's place in the solar system. We've long believed we had only one moon. Then we discovered the occasional mini-moon, tiny asteroids that briefly fall into Earth's gravitational grip, orbit for a while, and then escape. We also learned about quasi-moons, objects that appear to orbit Earth, but are actually caught in complex solar orbits that keep them near us, like companions on a cosmic racetrack. But the Cordillera clouds, they are something else entirely. They are not captured asteroids. They are not temporary visitors. They are persistent features of the Earth-Moon system. Ethereal, yes. Fragile. Absolutely.